So we hear it all the time, right? The planet's warming up. But have you ever stopped and wondered, why can't scientists just give us the exact playbook for what's coming next? Well, let's get right into it, because the answer is actually the super fascinating puzzle about our climate's future.
I mean, it feels like we should have a straight answer, doesn't it? We've got these incredible supercomputers, decades of data, and yet a crystal clear forecast is still, just out of reach. So why? What are the big unknowns that make the future so tricky to nail down?
And here's the thing, it's not because we don't know enough. It's because the problem itself is just mind-bogglingly complex. The best way to think about it is like a giant, epic puzzle. And to actually see the final picture of our climate future, we have to piece together three totally different and super unpredictable kinds of puzzle pieces.
All right, so let's grab that first piece of the puzzle. This one is all about the natural world itself. See, the Earth has its own built-in safety systems for keeping the climate in check, but how they're going to behave in the future, that's a huge question mark. Okay, so the planet's most important safeguards are these things scientists call carbon sinks. Basically, they're natural systems. Think about our massive forests, the deep oceans, even the soil under our feet. And they are so important because they act like these giant natural sponges, literally soaking up a massive chunk of the CO2 we're putting out there.
And this is exactly where that uncertainty starts to creep in. Because on one side, these sinks are absolute workhorses. They're absorbing a huge portion of our emissions. But on the other side, all the pressure we're putting on them, things like drought, deforestation, warming oceans, it's weakening them. So that creates this enormous question. Are they going to keep helping us out, or are they going to start to falter and absorb less and less carbon down the road? We just don't know for sure.
Okay, let's put that piece down and pick up the second one. And honestly, this might be the most unpredictable piece of the entire puzzle. It's us. Our collective choices, our decisions, they are a massive, massive wild card in this whole climate equation. When you really get down to it, our future impact on the climate pretty much boils down to three big things: how our economies grow, how our global population changes, and maybe most importantly, where we decide to get our energy from. And the path we choose for each of those, it creates a completely different version of the future.
It's a pretty simple cause and effect, really. As the world's population gets bigger and more people, especially in developing nations, get a higher standard of living, well, the global demand for energy and resources just goes through the roof. And that trend is a huge engine driving what our future emissions could look like.
And this chart, wow, it just lays out the stark choice we're facing. Look at this. One path shows our emissions skyrocketing if we just keep on relying on fossil fuels like we have been. But the other path, a fast switch to renewables, it looks totally different. Our energy choices really are one of the biggest levers we can pull.
All right, now for the third and final set of puzzle pieces. And these are the most complex and maybe the most dangerous. These are the real wild cards in the climate system. Things called feedback loops and tipping points.
So what on earth is a positive feedback loop? Yeah, the name is kind of misleading, because in climate science, positive is not a good thing at all. It actually means a vicious cycle. It's when a small amount of warming triggers some effect that in turn causes even more warming. And that just amplifies the whole thing, again and again.
A perfect and kind of terrifying example is the thawing of Arctic permafrost. Here's how it works. The planet warms up a little, right? That causes this permanently frozen ground to start thawing. When it thaws, it releases enormous amounts of carbon and methane, which is a super potent greenhouse gas that have been trapped for thousands of years. That gas makes the atmosphere warm up even faster, which, you guessed it, thaws more permafrost. You can see how it just feeds on itself.
So, if feedback loops are like these vicious cycles, then tipping points are more like walking up to the edge of a cliff and falling off. They are these critical thresholds where, if you cross them, the entire climate system could suddenly lurch into a totally new state, often really, really fast, and the scary part is maybe irreversibly.
Two of the big ones that scientists talk about are the potential dieback of the Amazon rainforest, which would flip a giant carbon sponge into a giant carbon source, and the shutdown of the ocean's massive conveyor belt currents that basically regulate our weather all over the world. The massive uncertainty around when, or even if, we might hit one of these points, that's one of the scariest parts of climate science.
Okay, so let's take a step back. We've got our three puzzle pieces on the table. Earth's own safeguards are getting weaker, our own human choices are a total wild card, and then we have these dangerous climate tipping points lurking in the system. So when you put it all together, what does the big picture actually tell us we should do? Now, you might be thinking, with all this uncertainty, maybe we should just wait. Wait until we know more before we do anything big. But what the science is telling us is the complete opposite. The very fact that we don't know exactly how bad things could get, that in itself is a hugely important discovery.
And really, this quote from the material we're looking at just hits the nail on the head. It says that in a system that's so full of unpredictable variables and potentially catastrophic tipping points, that uncertainty, it's the very thing that makes it essential to be cautious, to take action now to manage those risks.
And that really leaves us with one last, incredibly powerful thought to chew on. When we know that the range of what could happen is so wide, and that these game-changing wildcards are out there, what is the real cost of doing nothing?